and welcome to the March 2025 edition of the IoT Security Foundation monthly webinar series. Today's broadcast is the 25th installment, and IoTSF members can watch recordings of every one of those 25 past webinars by going to our members-only platform, where you'll find details on the plenary message board. There's also a special webinar recording on the Radio Equipment Directive, otherwise known as RED, which is exclusive to IoTSF members as well. If you're not an IoTSF member, you can watch shortened versions of our past webinars on our YouTube channel. And if you're watching this broadcast live today, I'll put the link for our YouTube channel in Zoom chat. Up next, we have Richard Newbould of Vodafone. Richard has over 17 years experience in telecommunications and consulting. That experience has spread across several disciplines, including submarine cable networks, public safety networks, defense, and of course, the IoT. As always, if you have any questions or comments on what you're about to hear, please put them in Zoom chat if you're watching this broadcast live, and we'll put them to Richard during the Q&A section, which is coming up very soon. Richard's talk title today is written as a question: the Internet of Things or the Intranet of Things? So we now cross over to Cornwall. Richard, the floor is yours, my friend.
Thank you very much, Chris. Afternoon, everyone, or wherever you are watching. I will just share my screen. Bear with me. Can you see that okay?
We can see that. Great, Richard. Thank you.
Lovely. Okay, so thank you very much for the introduction, Chris. As Chris mentioned, I'm going to try and do a little bit of a high level over the Internet of Things, or the intranet of things. And it's interesting in Murat's talk earlier about the normalization of what he's doing, or the normalization of security around the topic that he spoke about. And that's something that will flow a little bit through my talk today as well. So the Internet of Things, or the intranet of things, if you had a look at this diagram, which is pretty basic, but if you went and looked around your house, or you thought about the devices you're involved in, whether you're selling them or buying them, there isn't necessarily a normal way, or the right or wrong way at the moment of connecting those things. So I had a look around my house earlier. I've got a connected car, I've got a connected heating system. I had my dishwasher even has connectivity. I haven't bothered connecting it, but it's there if I need it, should I think that it can do something magical. My fridge and my freezer have connected capability, and again, I've not bothered connecting those really. I had a little look about what they could do, but unless it's going to start making my sandwich for me and pouring me a drink at midday, I'm probably not going to connect it just yet. So anyway, there are so many things out there now. We're in the billions of connected devices, and it's only going to grow. But there's a very different way in which these things are connected. Some of them are just sitting on the side of our countertops. They're connected via Wi-Fi or through some other radio means, and some are connected through SIM cards. And it won't surprise you that most of my discussion is focused on the Internet of Things, as we've termed it, through SIM card connectivity. So let's have a little look into what sort of options are available. So a lot of people in the Internet of Things, when they come to us for connectivity, they're really thinking about connectivity at quite a late stage, we tend to find. But it helps a lot if connectivity is baked in as a factor at the beginning. So are you just going to connect this with a basic SIM card device option through the consumer network that we all know and love with our mobile phones? Or are you going to think about a few more questions? And I've got some of those questions on the screen here. So for example, if you're connecting via a radio network, is that radio network following a standard? For example, is it part of 3GPP standards, which is what we use in Vodafone in our radio network? It's not necessarily part of those standards, but it is providing a radio network of sorts. What other options have you thought about with your device, or what options has the organization that you've bought that device from thought about in terms of the SIM card that may be within it to connect it. So is that simply a plastic SIM that you pull in and push out? Is it a soldered SIM into that device? Or is it even an iSIM where it's built into the compute chip within the device itself? And there are options there which change the game in terms of the connectivity and both the physical and connectivity security options that you have. Have you got the ability to lock that SIM to that device if it is just a plastic SIM? And what controls is there for that SIM in terms of authenticating against your IT stack or against the network that you've chosen? And some of these things might not be available if you go down the route of choosing a SIM option that isn't IoT dedicated. And that's really one of the focus on today's call and talk is around where should I go with my connectivity? And ideally, I think that some of these things that we saw on the first screen there should consider the normalization of IoT and a dedicated IoT connectivity path. So other options that you may think about when you come to connecting your device is that device actually connected through a core network which is dedicated for those things? Is it relevant to those things? Or am I just thinking about it in the same way that I think about my mobile phone or other consumer device that you might buy in the market and provide a consumer SIM for? There are other different options available with an IoT dedicated connectivity solution, such as peer-to-peer connectivity, whether that's blocked or not. Is that relevant for your device? In many instances, especially critical instances, that's quite a key feature, which reduces the DDoS attack options there as well. Are you using private APNs? Are you just using an open internet APN? Have you considered the backhaul from the core network that may be being delivered by a mobile operator? Are you just going to use the internet there, or are you going to use encrypted links or some other dedicated private fixed line link? So another set of considerations to think about. And then once you are up and connected, what can you do with your devices? Does the connectivity option that you've chosen actually allow you to manage your estate of SIMs easily? In the consumer world, if you just use a lot of consumer SIMs in IoT devices, for example, there's not necessarily an IoT dedicated management platform to manage all of your consumer SIMs. Okay, you can log on to maybe your consumer SIM account and see what that's going on, but that's totally different to the management level that you've got with an IoT dedicated connectivity solution. And there's lots of other things that you can think about, like what networks that roams on, what alerts that system might provide you, what information are you looking for from your IoT estate in terms of analytics, what sort of thresholds do you want to put in place, what might trigger your SOC and SIEM to get into action. So there's plenty of other options available when you consider a dedicated IoT connectivity solution that may not be available to, let's say, just a connected Wi-Fi dishwasher or your consumer SIM that you might put in your mobile phone. Okay. So let's just have a quick look at this at a high level then. So if you have a look at the yellow line to start with, you will see that you've got your device on the left-hand side there, and we've got some radio connectivity coming across the right-hand side. Then it comes into a consumer core network for your mobile operator of choice. And that's effectively open then to the internet, and you can do all the things that you want to do on your mobile phone, as you know. Now, if you put that into your IoT device, that's what you'll get. You're just going to get the consumer core and the open internet connectivity. Of course, you can add layers of security over the top, which we will look into in a little bit, which is where I've got the blue line. So you can add your application layer security over the top of an open internet connection, for example. And that's something I would always encourage. I would always encourage people to deploy application layer security, because it really gives you that end-to-end encrypted security that you're looking for with your data. But with a IoT dedicated service, you've got more options. For example, you're in a private core situation. It's a separate core to the one that the consumer network uses. It's much more shielded. You cannot address from the consumer core world into the private core world in terms of your IoT devices. I can't reach from my mobile phone your IoT devices because they're on a completely separate network effectively. And this is where we start to shift from the internet to actually potentially the intranet. Now, if your device is connected over this IoT dedicated network and it's using the private core, for example, then it's still potentially possible that you might decide to use internet as a backhaul back to your IoT stack or data center. And that's absolutely fine. Obviously, you and others and myself would always encourage you to protect that connectivity backhaul. And lots of people may use IPsec over the internet, for example, as a common choice, or you may use a fixed line. But we're only talking about the backhaul there, which, you know, is not it's a part of what's going on here, but it's not at the front end, and it's a little bit less exciting than what we're talking about in the IoT world. So if you choose the fixed line network, for example, you have effectively got a private network here. You've got your IoT device on the left-hand side going through an IoT private core over a fixed line backhaul to your IT stack. That's a private network, and that is the intranet of things, no longer the internet of things. And this is mainly where I work day to day. Most of the things I deal with from a connectivity point of view are using that type of connectivity. And so they're actually sitting in an intranet of things, non-addressable from the outside world, unless, of course, there is a purposeful need or request to have some sort of internet breakout. Okay. So let's have a quick look then at the layers and options that are available to everybody when they're deploying an IoT solution. So we've got our IoT device on the left-hand side. Now, as it happens, this device is capable of, has some sort of level of capability, but that's maybe beyond what you might have in the field. Some devices are powered, connected to mains. Some have a different level of compute to others. Some might be battery operated and have battery constraints. Some might be incredibly small and compute is lacking in comparison to, let's say, a router or some other device that's out in the field. So the first layer that you can choose for your IoT device is to put it in a private APN. So the device will register with the network, with the HLR, and it will check that the APN that's been requested is part of the home register, and it will do a challenge response to make sure that all these details are as expected, and that challenge response will take place and authenticate the device onto the network, and with the Radius server that's either in our network or passed on to a Radius server which is within your network or our customer's network. And at that point, that device has a connection, an IP connection, and data can pass. So at this stage, you're now in a private APN, and you're not just connecting over a public APN over the internet, for example. And this is where you start to now move into, at the very start, from the Internet of Things into the intranet of things, because you're within a closed user group. Okay, but what else could you do? What else is your device capable of? So once you've got your private APN set up, you could make use of a VPN over the top of that as well, and run an IPsec tunnel from a VPN capable router on your side to a VPN capable device at the other end. Now, that's not always possible, and I'll go on in the next couple of slides to show what other things people do to mitigate that. But effectively, this is another option where you can add a VPN IPsec tunnel on top of your APN. What else can you do on top of that? You could add a TLS layer. So on top of your private APN, a TLS layer over your VPN layer, and your private APN layer. So now we're adding serious levels of protection and security. Now, you're probably thinking, okay, these things are only going to work for devices on the left-hand side which are capable of handling these, and we've still got that last stretch on the left-hand side to maybe get to a device that's beyond that. So if your device is one step in and it's capable of handling this type of security, then that's great. But if you need to produce another signal or another radio level connection onto your device beyond that, then we start to think about what we looked at in the first slide. So at that point, then you're thinking about application layer security. So the application layer security running from between your device and your application server can actually sit end to end. And so in one situation, though it's not necessarily common to every IoT situation, you can have your private APN, your VPN, your TLS layer, and your application layer of security. And that is security in depth from a connectivity point of view. However, many devices that are in field are not necessarily capable of maybe running an IPsec tunnel or maybe the TLS layer. So what's more common for a number of devices that I work with is that they'll be running that application layer security over the top of their private APN. And that provides a strong layer of security between the end device and the IT stack. Okay. So what are the choices? So as we discussed at the beginning, there are actually many choices from a connectivity point of view out there, and it's the normalization which is something that I would like to see a bit more of. I can see in the field, and I have many discussions out there where we're still connecting a number of devices via Wi-Fi or a consumer SIM, and it's not necessarily wrong, but how do you know what levels of connectivity security are deployed in those situations? Is that connectivity security that's been provided for that situation actually good enough for the situation that's been deployed in, whether that's in your house or something that you use that's quite critical to you? The device that you've purchased may be used in a different way by you to what was intended by the seller. So it's a question then of what security has been put in place for that device in the way that you're going to make use of it. So I think the normalization of things in terms of connectivity, it would be good to see, and obviously we have millions of connections that are using SIM-based connections and making use of these different layers of connectivity options. And I think it'd be good for us to move the Internet of Things, whether it's SIM-based or not SIM-based, into what I would consider to be the intranet of things. And certainly in my day-to-day work, everything I tend to deal with is actually sitting more in that intranet of things rather than the Internet of Things. I think what we've just simply done, in the same way that cloud did to the IT stack in a data center, is that in society we've tended to term the internet for all and any connectivity and just a means of talking about something that's smart or connected, whereas actually it's actually a far more complex situation out there in terms of what's using the different connectivity options and what they've done at both the device end, the IT stack end, and at the connectivity in the middle, in terms of the choices that they've made. So there are the choices out there, and I would encourage everyone to consider connectivity choices at a much earlier stage than what I see tends to be a lot more focus on the device itself, which is obviously important, but that will have an effect once it goes in the field about what connectivity choices have been made. Okay. Thank you, Chris. I think that was my last slide.
Fantastic. Thank you very much indeed, Richard. I mentioned at the start of today's broadcast that we recently did a special webinar on the Radio Equipment Directive, otherwise known as RED. The recording for this RED special is exclusive to IoTSF members, and you can watch it by going to the plenary message board on our members-only platform. Our next webinar, by the way, will take place on Thursday, the 24th of April, and it will feature Ramy Shelbaya of Quantum Dice speaking about random number generation. We'll also hear about post-quantum cryptography from Daniele Fronte of Seal SQ. Daniele, I know you're watching today. I hope you've just I hope I've pronounced your name correctly. Excusez-moi if I have not. If you're watching this live, you can register for that now. The link is in Zoom chat. That's Thursday, 24th of April, random number generation and post-quantum cryptography. If you've not signed up to receive the free IoT Security Foundation monthly newsletter, I'll put the link to do so in Zoom chat for those watching this broadcast live today. It features upcoming webinar details, webinar recordings, details of events that are going to be taking place around the world, blogs, member news, publications, and lots more. It's always a quick, skimmable read, and we promise not to spam you. So like I say, if you would like to sign up to the IoTSF monthly newsletter, I'll put the link in Zoom chat in just a few moments. As Murat